สวัสดีครับอาจารย์ and พี่บูม We are Panda ฉลาลม or Smiling Panda. For this video, we are going to talk about the technical aspect of our DPMS data warehouse project. So let's start with the agenda for today's video. First, we will talk about the project overview. Second, the design and implementation walkthrough. And lastly, technical aspect including ETL and Q. So our challenge for this project is to find interesting insight for the shopping mall data. The data cover information about 3 distinct malls, 4 AM, 4 PM, and 4 Plus. There are 2 types of shop, tenant and retail. This is the summary of data we were given with. However, after playing around with the data for a little bit, we found that there were some areas we could improve on in order to make our analysis more interesting. So we decided to do some data cleaning and data mocking first. With the current dataset, the member profile table contains a lot of new value for the attribute age, income, and marital status. We figured that these attributes about customer demographic are all interesting. We could perhaps use it for the analysis. Therefore, we decided to fill in the replacements with random value using SQL script. This is the example of SQL query we use to clean data.
Next, let's have a quick look at our solution overview. So here we have the conform bus metric for our data warehouse, which shows that we have a total of 5 fact tables, which are the sale line transaction at a retail, payment transaction at a retail, sale transaction at both retail and tenant, monthly snapshot of each shop total sale by members card type, and promotion transaction at a retail store, and then 10 dimensions, which are product, store, promotion, member, date, time, tenant, payment type, and card type. And so in order to start our design process, we did the 4-step design. For our first fact table, we want to analyze the business process of sales transaction at a retail store, and the granularity of which we are analyzing at is the individual sale line per receipt. The dimensions related to it are date, time, store, member, product, and the degenerated dimension that we use to trace back to the original database are transaction ID and sale lines. The measure that we are measuring as are displayed. For the is return measure, if it is a return transaction, the value will be 1, and if it is not a return transaction, the value will be 0. We can later use this measure to aggregate the amount of return on a particular date or a particular product. Next, for our second fact table, we want to analyze the business process of payment transaction at a retail store. The granularity of each row is payment type per receipt, and the dimension related to it are as follows. The measure is the payment amount. And for our third fact table, we want to analyze the sales transaction of both retail and tenant store. However, since we have receipt level information for tenant store, the granularity is each individual receipt this time. The dimensions associated are as follows. And since in one row it could be either store or tenant, but not both, either the store or tenant key will be null, so we have had used the special surrogate key for the null value. The measure for this fact table include net sale amount, earn point, and is tenant or is retail.
Our fourth fact table is an aggregate fact table to fact table 3. The date and member dimensions are shrunken to month and card type dimension respectively, while the store and the tenant types remains. The measure are summed from net sales amount and point earned based on month and card type. Our last fact table analyzes the discount activities. The granularities of each row is the individual discount code and type in a sale line, and the measure is discount amount.
Next, let's have a look at each dimension in a little bit more detail. The first dimension is the product dimension, describing information about each item sold at the retail store. This table also contains information about product category, and since more than 90% of the product have 6 category levels, we decided to use fixed hierarchy and add 6 columns for each category. The maximum number of categories is 6, so the product with less than 6 categories will have some null value in some category levels. We decided to use SCD7 or the dual type for this dimension, which means that we create another dimension which is the current product dim to help keep track of the current product. And when there's a change to any of the attributes in this dimension, a new row will be appended. The second dimension is the member dimension. This dimension stores member profile and their card type information. We decided to use SCD5 for this dimension since member demographic information such as age band, gender, and income band could change rapidly. Therefore, an additional dimension called member demographic is created as a mini dimension. When a new row is inserted into a fact table, both the member key and the member demographic key will be created. The member demographic key in the fact table represents the member demographic of when that transaction happened. But if we want to know the current demographic of a member, we can use the current demographic key.
The third dimension is the store dimension, which keeps track of all the retail stores. The fourth dimension is the tenant dimension that keeps track of all the tenants. For both dimensions, we using STD2, which is append the row whenever there is a modification. The fifth dimension is the payment type, which is used to analyze the payment transaction. The sixth dimension is the card type, which is used for the aggregate fact table. And the seventh dimension is the promotion dimension. The payment type and card type dimension is STD0, whereas promotion dimension we are using STD1, which is to override any changes. These three dimensions are related to the transaction date. We separate date dim into two separate dimensions, date dim and time dim. A month dim is created for the aggregate fact table. The STD used for this dimension is STD1.
And now, let's have a quick look at a summary of the data warehouse technique we have used. So we use this generated dimension in our fact table so that we can trace back to the original database. Next, marquee is used for date dim to help with query performance, and an aggregate table for transaction fact called monthly transaction fact is also created to speed up the query performance. The special null surrogate key is used for tenant key and store key for whenever there's a null value. Mini dimension is used for member demographic dimension as a part of SCD5 for member dimension. And fixed hierarchy is used for the product category hierarchy.
So now let's have a look at other technical aspects, and let's first start off with the ETL process. This is the summary of the ETL process that we have. We separate them into two groups, initial and SCD. Initially, we loaded the date time information first, which includes date dimension, time dimension, and month dimension. We also assume that payment type is fixed and can't be changed, therefore we group it with the date time information in the initial flow. In the initial flow, these are the data that can be populated beforehand and only needed to be run once. The second group is the SCD group, which first load all the different types of dimensions according to its corresponding SCD. The dimension loaded here are product, current product, member, tenant, store, card type, and lastly promotion dimension. After loading all the dimensions, we then download all the fact tables. Now let's have a look at how we load the product and the current product dimensions in a little bit more detail as an example. So for the product dimensions, we have to create an additional columns to collect the status of each row. There are two available status, current and expired. If there's a change in any of the attributes, then a new row will be appended. We set all the attribute as historical attribute in the SCD process. For the current product dimensions, we have SCD1, where we set all the attribute as changing attributes that will be override when the data is modified. Another interesting dimension is the tenant dimensions. We decided to set most attributes as historical changing. However, for the attributes is active, we decided to allow it to override. After loading the data into all the dimensions, we then load it into the fact tables. So this is an example of an SQL query we used to load the data into fact table 1 cell line transaction fact. We had to join the cell transaction tables to all the different dimensions in order to get the surrogate key needed to load into the fact table. And this is the mapping examples of 4 cell line transaction fact.
We decided to implement the cube for better query and analysis performance. We implement the cube on Fact 2, which is retail transaction payment fact, and Fact 5, which is discount transaction fact. We add some hierarchies on date, time, store, and member dimension table in order to drill down when performing analysis. We pre-calculate some measures in the fact table, such as sum and average of the payment amount, and create the partition based on time period. And next, we use the cube to analyze in the Excel to gain some more insight. For example, this is a table of total payment amount. Each row represents amount quarterly and can be drilled down to monthly. Each column represents each payment type, including cash, coupon, and etc. And also, we can filter using the store category, which in this table, I choose PM Store. And that's all for our data warehouse design and spatial technique. Thank you so much.